welcome to another stream. How's it going? So today we're working on editor Gizmos. Last stream we got the placeholder asset system in. So what we need to get, just my levels here. There we go. So what we need to get done is a gizmo, so essentially like a way to click and drag things and move things in the editor and scale and rotate. So we need that for the level editor and the model editor as well. So we already have a lot of the debug drawing side of things for these. We're just missing. Oh, I got the wrong file again. We're just missing the torus or the ring, whatever you want to call it. Here it is. So we've got the ways to draw vectors, so we can draw the X, Y, Z axes, right? Quite easy. We've got the an OBB, so we can draw like the planes to get the dragging along the planes and things. Let's get some images of that. Gizmo, editor, like that. There's a good picture. One that's not a terrible picture. Yeah, basically stuff like this, right? These are quite terribly done, but you know, we can do these planes, we can do these arrows. We can do these as well. They're not too hard to do. This is scaling. But yeah, we need these ones like a torus one. So the way that we're currently doing our debug drawing is we're using ray tracing. And per pixel, we're just testing against every single debug shape. It can probably be optimized in the future, but currently it's just the way it works. So yeah, we're using ray tracing. There's a ray trace function for a torus. That'll help us get the rotate one. But it is quite a bit long. Maybe in the future we should switch to a ray marcher one instead, because I think the ray marching torus is a lot more simple. Yeah, it's a couple of square roots, basically. So maybe we should switch to a ray marcher at some point. Do that instead, because it's got all the shapes we need, and these they're a lot more, easier to express in array marching forms. Yeah, perhaps in the future we'll do array marcher. Wait. Let me take a look at the shader that does it. Draw 3D. So I think in Draw 3D, the shader, this is the implementation of Draw 3D render, here we go. Wait, we could just do the ray marcher in here. Yeah, that'd be easier. So we just did a ray marcher. The SDF function would be cheaper. And then we can sample the normal. Yeah, that should be alright. Yeah, let's do that, that'd be cool. Yeah, I hope everyone's having a good day. So let's just make a quick ray marcher. Not too hard to do that. So where's the torus? Well, we need to pass in the data first, isn't it? So let's go to those draw 3D functions, and let's do the torus in Let's do one in world space and then do one in should we do it in world space? Yeah, it might have to be a bit of a rotation to it as well, actually. Yeah, let's say you have to get it into view space. So or maybe we should do a full-on matrix, isn't it? Like the OBB. You do so that this way we can support like rotation and things. That could work. So view from local space of the torus that we're trying to draw. And then that way we don't need do we want like an offset in like a position in local space maybe? Not really. Yeah, let's just pass in a matrix and just draw it like that. Oh no, you'll need some radiuses, wouldn't you? You'll need a thickness. And then a color. Yeah, let's give that a go. So let's do all the plumbing for that. So the thing is about this API is there's two implementations. There's one implementation for CPU and another implementation for GPU. So it means we can debug draw stuff in shaders and CPU side. So what we're going to have to do is implement it twice. Let's just find one. This is the GPU one because it's in the shaders.c file. This will basically get a buffer and just add a bunch of words and write them into the buffer. All right, torus. And then where's that view from local? We've done it before. Yeah, the OBB. Right, now it's got to change these. Torus. How many words does it need? Well, it needs 12 words for this. Right, 12 floats. 13, 14 floats. So it's 14 floats instead, right? So it's torus. All of the axes and then the translation, right? It's just a matrix. We'll say 4 by 3 affine matrix, is that what it's called? Where it's gone implicit, fourth row. So we only need 12 floats instead of 16. And then we want to do the thickness of it in local space, right? Yeah, it's got to be like probably very small. But anyway. Why don't we let thickness in view space one? Cool. So that one wasn't too bad. So let's go ahead and implement that in the CPU side. There's another one. Looking for ellipsoid. There's underneath this one where we put it. Here's the CPU side one, so it works with pointers, right? Instead. So let's go back to the header file quick and copy the prototype. But did I zoom in? I didn't zoom in. Right, it should be better for you guys. Okay, so we want 14 words instead of 15. Then we would like change that to ellipsoid. No, sorry, chorus. And we're going to push on all the words. Wait a minute. I did need 15. How did I miscount that then? Oh yeah, because the first word is the header, which stores the type in there, and then the number of words in the higher bits. Right, stores the number of words in the higher bits, and the Z test in the highest bit. Right, that makes sense. Let's go back to that torus on GPU and quickly correct that one. 15. Excellent. So now we've got the API sorted out. Let's do the implementation on the shader side. If we found out if we use ray marching, the torus implementation is actually dirt cheap. It was easy. It's a lot easier as well. Far more simple than the ray tracing equivalent, right? So if we just write a quick little ray marcher and use the signed distance torus, we should be able to get it working pretty easy. So if we go to the draw 3D render shader, just a compute shader launches 8x8, a full screen render basically. Let me find a. Here we go. Oh, okay, let's drop it in here. So, SDF torus. So P is that yeah, I think P is it's in the local space of the torus, and it's the position of the ray where the ray is currently marched, and it gives you the distance from there basically from a point. So, and then T is actually the torus parameters. So if we actually name them properly, one is torus radius, and the other one is torus thickness, shall we say. Right. It's interesting, it goes down to 2D, so it must... Huh. Interesting. So simple. Alright, that's good. That'll work. So we've got to write a nice little ray marcher. Should be able to do this off the top of my head. So here we go. So effectively, so what do we need to be able to do? Oh yes, we need to extract out the parameters from the word from the words buffer. So we put them in a buffer of U32, and we just got to unpack them back out effectively. So we look at the OBB one. Should have all the ones that we want. So all of those, and then this one is thickness. So now we've got all our parameters. So the thing is, right, is that we actually need to, so the sign distance fill function is operating in local space of the object. So we actually need to turn the ray into local space and the ray direction. So there's ones that actually do that in the there's other ones that do it. I forgot what it was. It's the OBB, wasn't it? Yeah, so we do an inverse. Yeah, it's like this basically. So like the OBB, the orientated bounding box, we instead inverse the view from local matrix, and then we take that ray origin in view space and ray direction in view space and move them from view into local space, and then now we can commence on the ray marching. So the idea is we probably have, I think it's a variable t, which is basically how far it's stepped. You start off at 0, and then you do your while loop. So really, we should probably have a max iterations. So let's go ahead and do like a let's say iterations as a max of 128 steps. And effectively, what you want to do, probably have like an epsilon as well. We can call it like min distance. I don't know, we can tweak this number. Like, the bigger the number, the more performant it is, but the less precision it is, and the more the less precise it is. So with a ray march, we basically want to do the SDF of the torus. Now P is that the position of the ray in the local space of the torus. So we have already moved the ray origin and direction. So to calculate P, it is simply just multiply by a scalar of ray origin and your distance you've traveled. So obviously first iteration hasn't traveled any distance. And then the next one is the radius. How big is this thing? Now, since we're in the local space of the torus, local space is typically -1 to 1. So a fill-on radius would be, and that's what we're going to do, I think. And then thickness is something we pass in, like that. So this will get us a distance. So when we hit the torus, it will be very close to 0. And this is where min dist comes into play. If min dist, or if distance is less than or equal to minimum distance, we are then going to break out this iteration. And then other than that, what we're going to do is take t and increment t by distance. So we'll keep going around in the loop, and we'll keep querying how close are we to torus, and we'll then keep going. So we until we either hit here or we reach maximum iterations. Now this code is a little bit yeah, I think that's fine. So we'll keep going until we run out of iterations or until we actually hit it. So we hit it. we will set the has hit to true, and then with this we can actually finish up and do what the other things do. So there's like a closest hit. So we've got to transform it back into view space, isn't it? Yeah, so we've got to transform it back into view space and then recalculate the t, and then basically say it's the closest hit if it is the closest hit. So, right. So we want to get our hit position in local space. So that is simply the ray origin in local space. Oh, wait a minute. Did I just do something completely silly? I forgot to multiply this by the, damn it. Right. P is ray origin in local space. So, okay, ray direction in local space multiplied by t along the vector, the normalized vector. That's your distance from ray origin. Yeah, that was incredibly wrong. There we go. So we add that vector to that position, and that will get you your p. So we do that again here. This is then our closest hit. Yeah, so now we need to move this into view space. So we simply just do the multiply point, and when we're multiplying with the view from local, and we're going to be obviously transforming that one back into view space. Now this is our hit position. Now we're going to calculate the hit t in view space, and hit t is going to be ray. So it's a length op versus with a subtraction between the hit position in view space and the ray origin in view space. Now that is our hit t in view space. We compare against the closest hit depth, the test depth. And then if we are the closest, we will set the closest depth to what we have said we are. And then the color, which we've read from the words buffer uploaded from the CPU or GPU. And then the normal. So the normal is one of these ones where when you do array marcher, there's a little trick you can do to calculate the normal. I should have just searched it. There's a little trick you can do to work out normals. If I just find... If you sample the scene in the XYZ by a tiny offset, take the difference or something like that, it gets you the normal basically. Yeah, something like this. Yeah, I don't know about this one. I've not seen this one. So yeah, you're offsetting it by some tiny epsilon. Right, that's interesting. Yeah. So yes, where our Taurus SDF will go in basically. There's another way you can do it. It's just sum them all together and then yeah, I get the gist. We'll just write it out. Um, so we can calculate the normal in local space. So normal in local space is effectively what we'd like to do is produce a, if you add them all together, then normalize it. So yeah, it's not the same as the one that's suggested, but this should be good enough considering for what it is. So we take our sample position, which is our hit pause local space. The radius, which is 1, and then the thickness. Now we just need to add here, add a very tiny amount, right? So that tiny amount, I guess we can do this min dist or something like that. Should be alright. Or maybe normal dist, I don't know. Something like that will do. Yes, you offset it by this thing along one axis. So x. Cool. So right now. Yep. So you need to add though. So it'd be like an add normal local space. Cool. So we do that across the x, y, and z. Well, we could probably do a bit of swizzling. Oh, maybe that's what the trick. Maybe that's what he was doing in his trick. Right, that makes sense now because the swizzling is just a way of. Yeah, so it's minus ones in the other one, didn't it? That's why it's a vector 2. It's just a way of selecting between two and making it neater, right? So, right, so what I'm doing 0 is like a minus 1 as well, right? Whenever it's a y, it's a minus 1. Then multiplied by. I don't know why that just wasn't pre-multiplied here. Oh, because the direction is encoded. Right, you just want the direction in this case. I see now. I see what that's doing. Cool. Yeah, maybe we'll copy it then. Yeah, I'm not sure what the last one is about though. So that was either a minus 1 or a 1. Then it was pre-multiplied by like a half, kind of. But I don't think we have to do that. Or maybe you might have to. Yeah, because of 3 dimensions. Something like that. Let's just do it anyway. Cool. So, right, so we add. There's some mul. a vector, so we'll create a vector. Hopefully this works for my compiler, I think it does. I got swizzling. Then the SDF function, position plus that's still not it. Alright, that's good. So let's try that. Does that compile? Let me give that a build, just to build. Nothing called Taurus. Did I save that? Right, let's make sure that compiles first, because I don't know write that all out and I have to change it. Does not implicitly cast to a float. Is that a compiler bug maybe? Bit bizarre. Should go in there just fine. Do that, see what happens. Right. Hmm. Hey, Captain, how's it going? I'm doing good, man. Yeah, doing good. Just going to work on some gizmos today. Oh, got a tea here. But yeah, things are not going bad. Alright, is that better? Right, somehow I pulled the cable out. Just, I don't know what happened there. But thank you. Yeah, been good, doing good. Just been, looking after my boy yesterday. So we just, took him for a walk, had a bit of a play with him, and yeah, just hung around really, had some fun. Managed to get a good workout on yesterday. So other than that, it's been busy working, and yeah, just the normal things. How about you? I'm looking to understand and find out what languages, but find out sort of C. Yeah, C. Mm-hmm. C is the way. I don't understand why is this thinking it's a float. What's going on? Type mismatch. Oh, right, I'm being a dummy. We're crying out loud. Alright, let me go back to the code I copied. Right. Oh, it's a length op. Crap, that was bad. Right, that'll compile. Yeah, it wasn't a compiler bug. Where's this at? Nice, this is the lines I wanted to test to make sure they compile. I said I'm busy too, working and coding in the evenings when I get at home. Nice to see you making progress. Awesome. Yeah, we made an asset system in like one stream, just a basic one, placeholder. So anytime we load an asset, we load up through there so we can find all the places in the code where we load assets. In the background, I'm working on the encoder system because I got it to the point where it's basically done, but there's just a bunch of like in the weeds type of work. And it's just not really the best content to stream. And so in my spare time, when I get the chance, I put a little bit more time into working on that. I don't get much spare time, but it's going along gradually. And what else? But yeah, we're going towards actually starting making an editor soon. So we'll start with the material editor. By November, we'll definitely be starting. So yeah, the material editor will be the first one that we work on, and then we'll move on to doing like a model editor and a level editor. So we're just getting all the stuff in for that really. The encoder system is going to be used for that as well. And while we're building it, we can test out the encoder system, make sure it's all bug free as we can. Yeah, it's going to be pretty nice. What stuff you've been working on, Katsumoise? You're an engine in that? Hey, no idea. Yeah, I decided to do ray marching for the Taurus because I realized that my shader is not really opinionated about what it is. It just gives you a ray and a direction. Sorry, yeah, it just gives you a point and a direction. So it just gives you a ray per pixel, and you switch on it to figure out what you're doing. So we're like, oh, we're doing a Taurus. So I was like, I'll just write a quick ray marcher. So the ray marcher has just been quite easy to do compared to getting that function to convert across. But maybe I should do ray marcher for all the things. I don't know. But how's it going, Mr. No Idea? How are things with you? Oh, I did a multiply 3. Because I'm do 3D all the time, I get trigger happy on 3. Oh, that's where the bracket buggered up. No? Oh, it's an SDF Taurus. Right, yeah. Scale. Oh, we're close. So that does compile, so that's good. So, we just need to actually compute the rest. So, let's just copy paste all that. Now let's follow these things. Where's the normal calculation? So it's YYX is the next one. YYX, next one, YXY, and XSX. So for those who are just joining in and wondering what this is after you ray march, you need to calculate the normal. So the way you calculate the normal is you take the hip position and you offset it by a little bit across different dimensions, and you add all the results together and then you normalize it. So x and y, you take this either -1 or 1 times by this. If it's going forward or backwards across one of the dimensions, and all we're doing is swizzling to get it to be basically 1 on the x here and -1 on the y's, -1, -1x, and so on, and then, yeah, so that's all it's doing, and then we've got to normalize it at the end, and then you get the, norm, you get the normal, right? It's definitely an estimate, but it's, yes. So now we move on to view space. So if I do a normal view space, multiply a vector, that does rotation and scale. So because it scales, you have to normalize it again. Normal view space. All right, that'll be it. So that should be our ray marcher for the Taurus. So we've got it all plugged in. So let's just put it down in the middle of the screen somewhere and rotate it and see what happens. Let's put that in there. I ran out of Cokes, so I was left with peppermint green tea. I was looking up a proper circle versus ray detection, and damn, it's kind of complicated with so many cases. You might just do a few iterations of ray march and save yourself a lot of dev time. Yeah, that's what I ended up doing in the end, yeah. Yeah, so like, I think your suggestion was like doing the two. I was trying to think about your suggestion, and I think, yeah, the Taurus has to solve all those edge cases, because if you just take a 2D circle and try and do it in 3D, you got the problem where if you go through the hoop and things, isn't it? It's like, you know, you wouldn't hit either side, but you go through the middle. It's, yeah. So, and the other solution is to do like a plane. But then if you do a plane, you only get it, you don't get the depth. It's a bit weird. Yeah, so I just went with the remarch. A lot easier to implement. But yeah. You do a lot of things, complex things out of my reach. I do a lot of things that are complex out of my own reach. Sometimes. That's cool. You know, I'm learning a lot of things while I do these things. You know, we did like 6 or so months on research and development, and that was me doing stuff I'd never done before. But yeah, I for one stopped the engine. It was useful because I learned a lot of basics. I wasn't ready for 3D. Fair enough. Now I'm working serious this time on racing game on Steam. Amazing. In EA Max. Cool. I hope there's a bit. Here's a bit what we've been doing in early stages. Nice, nice, nice. Yeah, that's cool. You set yourself a year, which means you probably will take 2 years, right? Um, but that's cool. Nice. Is it like a card game? No? Oh, okay. It's a auto. What do they call these things? Nice. Not a card game. I thought card games they're the sort of desk here. But is there, oh, I forgot what it's called now. I guess you can call this like a bit like Plants vs Zombies, isn't it? Maybe. It's cool though. I like the little creatures you have. It is a tower defense game. Maybe. I thought tower defense was more of like a map, but I guess, yeah. That's cool. Well done. Yeah, if you want to get finished in a year, set yourself 6 months. Because it's very easy to overscope. And it's very easy to do 2 times or 4 times over. Um, yeah. I'm really bad at it. I think everyone's really bad at it, to be honest. And then people just usually fix the problem by going the other way and setting really long estimates. But yeah. So let's get this thing tested out. So we're going to gfx.c and we're just going to plant it in the middle of this scene. You know, do a bit of sign to get it animated. Where am I going with this? That's the BVH stuff. Frame start. Oh, where did I do another draw 3D thingy? I did them somewhere, right? Here we go. Just plop it in here somewhere. Draw 3D. Torus. So we've got to do a super lovely so there's a view from world. And we're going to produce a matrix 3D for a world from local. So if we simply just do a rotation matrix along the y-axis, we'll get it spinning around, yeah? And the angle will simply be a bit of sine. Wait, we don't need to do... We can always just throw time in there, right? Time set. Yeah. Plop that in there. Then to produce the view from local matrix, it is simply just the multiplication of graphics view from world multiplied with world from local. And then we just simply plot that in there like so. The next one is the thickness parameter. So thickness is in local space the object, so I did 0.25, maybe a bit big, maybe we'll do 0.1. We could probably animate that, to be fair. You know, why don't we just do a bit of sine on the time, multiply by 0.5 plus 0.5, multiply the result by 0.1. Maybe we'll like add, yeah, something like that. Add a little bit to it. Right. Color -1, solid white in your face. Z test, no, because I want to see it. Z test. Yeah, Z test doesn't need to be handled. Right. So if the stream dies, my computer's hopefully not blown up. But yeah, sometimes the it crashes the AMD driver if I index out of bounds, but we shouldn't have done it, right? Should be alright. Right, we're still here. And we got ourselves a Taurus. I didn't realize it would be laying down though. That's pretty cool. We got what we wanted, people. First time. Yay. And it's not Z testing, as you can tell. But if we put on the Z test, it will Z test. I don't know why it's not rotating though. That's my concern about it. Yes, I'm not rushing. I'm okay. I think I broke Z testing because I think it's the I forgot what it was that broke it. I wrote, I changed something, broke it. Classic. The Z test is currently broken on the debug drawing shapes renderer, but that's okay. Yeah. Let's sort out why it's on its. It's meant to be rotating. That's I thought it would be upright, rotating like a ring, like Sonic. Yeah, I'm not rushing, working on it when I come back from work. Awesome, some silly games with some simple graphics, made thousands of dollars on Steam. I don't have big hopes, but I'll see. Oh, you're talking about like Vampire Survivors, right? Yeah, that's cool. That's cool. But yeah, also you have something to show for it as well a lot sooner. So it's a good idea. And if you have fun doing it, why not? What the hell did I do? Why isn't that doing its thing? Because that does the sine and cosine of that, right? Is there something wrong with this time? Is time not advancing? No, time is because the sine one is moving, yeah? What have I done? Oh, right. I'm rotating on the y-axis, right? But I didn't realize that the thing is actually flat along the xz plane. Right, and I think... Oh! It's a sine distance function. So I think IQ likes xz, right? I don't know why. So if we change it to xy, that'll fix it in the sine distance field function. So now it'd be upright along the x and y plane. Right. That wasn't too bad to fix. There we go. This looks bloody big though. What's going on? Well, that's not what we hoped for, is it? Pretty big. Alright, maybe that weren't the way to do it. That's meant to be Z, maybe? Because I changed it around. Oh yeah. I didn't understand what I was doing, but it looks like I did. Yeah. Right, so... That's cool. Yeah, so now we've got all the primitives, so we can make our gizmos. So I guess let's write the API on how we want to use the thing. It's not going to be the best API, but we're going to make the assumption that, right, it's going to be quite simple. We're only going to have one gizmo active at a time. There's no point having multiple gizmos active at one time, because when you have one selected object, you have one gizmo. It's either the axes or the rotation things, right? Or the scale axes. And when you have multiple selected objects, it's typically a gizmo that goes in the middle of all of them, if you have such feature. I don't see a point of having multiple gizmos at this point in time, and if we need them, we'll add it in. It makes the API a lot more easier at the moment. So let's go to the graphics header. This is where this is our game graphics implementation, or sorry, header file. We have a sort of a payload that we fill in from the game thread. When we have a game thread, we don't have a game thread right now. It's all on one thread. But essentially, like, the game is going to produce a bunch of render data via the graphics payload, and then pass that to the render thread. And we'll probably just double buffer these payloads or something like this, and swap between them every frame. One frame, the game thread gets one of them, and the render thread gets the other one, and they swap. Right? The game thread always fills one up. The render thread always reads one. So this is a great way to communicate where I want the gizmo, right? So I want to say we probably want to have like where do we want to put the gizmo? Do we say into view space? So I think we'll just call it like a graphics gizmo. And maybe we'll have an enum. To be fair, you do probably want to have this on the... I don't know, let's just go with the flow. See what happens. Gizmo type. So graphics gizmo type. Translation. Rotation. Scale. Now, I don't think I need a count, to be honest. So we put the gizmo type in here. And then we also want to put in, so effectively, like in the editor, right, we will have some object that is in world space, and so I think what we want to just, it could be in any space, basically, right? So what we want to say is like, hey, I want a matrix that goes from to view space from something, some other space, but it doesn't matter. It's just got to go into view space at the end of it. And then what we want to be able to do is pass wait a minute. Yeah, then what we want to be able to do is pass in probably the offset in we probably want some position. Oh no, the whole point of the position is maybe it is from local. So this maybe has the because we want to take yeah. That's probably it. Okay. So I think what we're going to do is have our gizmo pass into the payload. And you might not, and that's another one, a none. Right, we don't want to show a gizmo. No gizmo rendering. Okay. So when you make the payload, you can pass in the gizmo to be rendered. Now, something that we also want to be able to do is in the editor be able to click down on the gizmo and drag it. So we need to know when it's being hit. Now we could go ahead and duplicate all the rendering code to do it CPU side, but there'll be, have to share code across files and things. So a couple of frames of delay is probably not too bad. So what we can do is just do it on the GPU and pass that information back. And this will probably be a thing we will probably do when it comes to like selecting ellipsoids that we've rendered, right? We do it on the GPU while we render it and send back the captured information. So we need a way to sort of like get some feedback. So we probably need a feedback thing as well. So the way I look at that is when you call render frame, it can give you feedback. So a piece of feedback that we want is, has the gizmo been pressed, basically, right? So Boolean has gizmo. Well, no, it's not being pressed. We just want to know if the gizmo is hovered over. That's what we want. Is gizmo hovered? So that's a piece of feedback that will come back through here. Okay. So that'd be pretty neat. Let's go ahead and adjust the prototype and then get rendering a gizmo. So from main, actually, where we do a render frame, let's just quickly make a little gizmo here. So the thing is the editor's gonna want to produce this graphics gizmo thing. So just make a nice little structure or something, and then we'll get it to be copied in. Gizmo dot type. So we just have a bunch of options. So 0 initialize it, and then we can enable the different options. So graphics gizmo transition type translation. Then we want the view from local. So the view from local, what we'd like to do oh, you don't know which one. You need to know what's been pressed. All right, hang on a minute. Yeah, we'll do that in a second. So maybe let's just have a bit of fun and say we've got Right, I think we should use that transform 3D instead. I've not tested this out yet, but I got it typed up. It's basically it's a matrix broken down into its individual components, translation, scale, and rotation. So if we use that instead, should be better. I got a function that converts it into a matrix though, so maybe we'll get to use that as well. Yeah, so if we did that, that could then mean we can actually modify it directly afterwards as well. That'd be cool. So why don't we have that? Right, so maybe we'll say, you know, if you press a button down, we'll change this. So we go if core operating system virtual keyboard key code has been pressed. Key code for, let's press the H key. So if that's been pressed, we'll say gizmo dot type plus equal 1, and then we'll, I guess, mod it around. So we'll need another one. I am. With GFX gizmo count, right? Cool. So that's how we try move it around. Now, we do need to identity if gizmo dot scale equals 0. Then what we actually need to do is identity identity. Have I not got one of those yet? Sanian. Yeah, I've not used this thing yet. It should work, hopefully. Transform 3D. Translation 000. Scale 111. And then rotation is quaternion identity. So that's 0001. Do I have a quat thing? I do. Nice. So let's take this for a spin and see what happens. Right. See identity. Okay. So this means then if we get back that feedback strut, bit of feedback. Graphics feedback, I guess we should call it. Now what we can do is say, right, the GPU's like, oh, you pressed on the X one, right? So maybe it's an enum, and it's called like graphics gizmo hover type. Nah, it kind of sucks. Let's just say like E32, Gizmo hover. So 0 is nothing. 1, 2, 3 are X, Y, Z. Respectively. Yep. Yeah, sometimes enum's just cumbersome. You know, we do a bit of maths and it should be maybe. Yeah, we'll see how it works out. Yes, we say if graphics feedback. Yeah, I think the rotation is not a. Is a quaternion, isn't it? So. Alright. So with this, we should be able to now move some things. So based on the type that we passed in, so check out the gizmo type. And there's all these guys. Alright. So for translation, we'd like to basically get. See, I don't really have array. I don't have array stuff for these. Like I could have put in. I could put an array in there, but it won't be compatible with GPU code. But we should really have an array in there, to be honest, in the union. Does make a ton of sense. Because it'll make this code a lot easier. But let's not use the array for now. So I put to do in there. So we'll just do the classical array, which is a pointer. So we'll just say, you know, gizmo. Wait. So in this case, it'll be a gizmo view from local translation. And then we'll do like a so it's graphics feedback gizmo hover -1 since 0 was nothing. And then here we're just gonna so we only want to hover if it's been clicked, right? So and OS virtual mouse. So for now, I think we'll just increment it, and we'll do a better version in a bit. But let's just get it working. So mouse has been button has been is pressed. Yeah. So and OS mouse button left. I'll do it. So yeah, we'll just increment it by some. I've got delta time here. I don't think I've got a delta time yet actually in my code. So we'll just do a fake delta time. Ought to be good enough. We'll just increment by a fake DT. I'm not sure how fast that's going to move, to be honest, but we'll find out. let's times it by 0.1. I need to take the address on this guy. Right, so that's the translation. I guess what we can do is just stick with that for now. And let's just get it all rendering, and then we'll fill in the rest afterwards. So now let's go and finish off the rendering. So inside the graphics side of things, we render a frame. We first want to make sure we set feedback Gizmo hover to 0. Right, so here's where the torus is. The test torus. So now let's go ahead and do a switch on the payload. Gizmo type. So based on that, we're just going to render a few things. Shouldn't be too bad, right? So the translation is we simply just take the Draw 3D API, and in view space, that's the thing, isn't it? So I should be able to draw the vector view space. The position being, right. See, if I did I could turn it into a matrix maybe, but... Right, so I think if we did payload, let's just test out, yeah, Gizmo translation. The vector is probably going to be multiplying a vector. You want to translate a unit vector, right? So you don't want to, you just want to have it rotated with no scale. Payload Gizmo. Right, what are we going from? So in local space of the gizmo, or of the thing that the gizmo represents, is we'll do a 0, or sorry, a 1, 0, 0. So that'll be the x-axis, one that we're drawing, right? Then we want to do a color red. Oh, a bit of thickness. So let's write a thickness in here. Maybe there's a, it's in view space, this one. I don't know, 0.01, let's give that a go. Thickness, then the color is color red. Because it's x, right? It's in the x space of the vector, so it's red. Then we don't want a z test, right? So if we just repeat that a couple of times, do the y and z ones, yeah? So blue, red, green, blue. Right, so let's take that for a spin, see what happens. Hopefully that works. We've not really tested it yet. But let's say you always hover down on the... Right, let's comment these out for a sec. Right, so we should at least see a gizmo in the middle of the screen, right? No. Right, translation of N00. I think this might have messed up. Should we get rid of the multipliers? See what happens. Or maybe the thickness is just way too small. That could also be a possibility. Because the torus was right here. Oh. Oh no, I thought I saw something. Yeah, the torus was right there. We can always maybe thickness is way too small. Let's make it 10 times bigger. Oh, my mistake. You know what we're not doing? We're not even rendering a gizmo right now because we've got the gizmo type of none. Press H. It should be here somewhere. Okay, that's the problem. Right, let's just force it to be translation. Still don't see anything. Classic graphics programming. Right, clearly this works very well. It's a 000 in view space. This is why it's a problem. It's a 000 in view space. Right. So we make it a world from local. Right, do I want it to be in... Get it into world space. And then from there I'll do whatever I want with it. Yeah, maybe that's the one thing I want is world space. Right, maybe that makes a lot more sense. Alright, so then in the renderer. Right. So if this does it in world space, I've got a world space one for that. So what this will do is take the coordinates and then put it into view space before it adds it. Is the view from world matrix, right, and brings it into view space and then stuffs it in the words array, and now it gets read on the GPU and rendered. So that's gonna work. We just gotta, yeah, they're a bit big though, obviously. So there is the, bring this back. So it should get the rotation. Let's just, this back to something. World. Okay. So that should obey rotations. But we haven't really got rotations yet. But we can go ahead and try. And just get one going, basically. So effectively, every frame, if we simply just do gizmo dot or from local dot rotation equals multiply quaternion with it, so itself, and axis angle, that's what I want, isn't it? Give me a rotation quaternion based on the axis, so the y-axis, right? I want to spin around like that. Based on some thing that we always increase. Now, we're better off probably faking that on the GPU side because we have a thing called time in seconds on there. Oh, I don't need to pump that into sine, it'll do that anyway. Alright, that seems sensible, I think. Alright, let's get Gizmo. Payload. Okay, so alright, we're gonna monkey around with that. Hang on a minute. Payload. Cool. So hopefully that gives it a bit of a spin. Bit of a spin. Right, they clearly bugged it all up, I think. You meant to normalize it. I think that's right. You need to when you multiply equal to you need to normalize them. Oh, I didn't see anything here actually. What did I mess up? What did I mess up? Nothing here. So I just added this multiplier back, I think. But don't we see it work? That multiply? I'm confused. Alright. So clearly this multiplier is actually already broken. So let's see the implementation. So it's meant to just multiply the rotation with the vector you pass in, and then copy the sine over from the scale. And then return that. Yeah. So an identity transform, which you should have done properly. So 0 on there, 1, 1, 1. We saw that, did we? Just throw a breakpoint in there and see if we actually reach here. I suspect we do, right? Yeah, of course we hit there. We hit the sig trap. Done. So that is going to produce an identity transform. Oh, you know what I'm doing? Somebody, that is me, didn't set the gizmo at all. I didn't even set it up. So it was an identity. I didn't pass it into the renderer. Classic. Right, so that is working now. it just was an identity, I think. Well, no, it just was an identity, right? So we move over to here. Let's bring this one in. So it should rotate now around the Y. Right, so I don't think we're normalizing the yeah, it's a bit thick, right? So let's drop the thickness down. I think we need to normalize the quaternion. I think. Right, that doesn't look right. Maybe we should move our quaternion back a bit. So let's hard code it to the translation.z. Let's put it to -1. Or 2. No, -1. Right, so I did move it back, which is nice. Let's move it a bit further back, actually. Oh, I pressed the thing. Okay, so what is going on there? The strange thing. I produce a rotation and I multiply the two rotations together, normalize it and store it back in. This then will apply the rotation to the axis vectors. Takes them from, local space of x, y, and z basis vectors and bring them into world space, right? So why do they appear to be different? Or why do they appear to cross paths? So the x one is moving, right? That makes sense. And the z, since the y is on top. Hmm. Right, I'm just going to take a quick break and then we'll come back and solve this problem. Right, baby. Alright, welcome back everybody. I think I thought of what the problem is actually. I've just been having a bit of a think, and I think my multiply unit vector function is wrong. I'm doing a copy sign here where I should be doing a flip here, but if the scale is negative type of thing. It's just like a multiply by the sign. Yeah. So yeah, so rather than being ABS V multiplied by sine, what we actually want to be doing is maybe we need to make a multiply by sine. Yes, you do like a mul sine like that. That's what you need. Got any more of those in places? No. Right, that should be the fix. So now the rotating should work. Oh yeah, look at that. Right, so we're rotating clockwise the thing in. Yeah, so we're moving it. Yeah, that's good. Nice. Cool. So let's just quickly do some testing and make sure it does work. So let's do it across the x-plane, right? The x-plane, the x arrow should stay still, which is the red one, right? And the other two should move, fantastic. And then we also want to do the z, which is the blue one. And then that should just rotate right around the nice. So my coordinate system is XYZ positive is where they point. So the lower left bottom, sorry, the lower left near is the 0, origin, right? And it's the same in 2D and 3D, just without the near and far in 2D, obviously. So it's like graph paper, basically. Yeah, so, oh, sorry about that. I was just pressing my thing over here. Cool, so I'm happy about that. That is the basis for translation. The thing we want to be worried about is that the thing I want to be aware about is we still need to do the clicking logic, which we'll get to in just a little bit. So let's do the rotation, things like that. Yeah, you see, I wonder how we want to do. Like, if an object is. Like, the thing that I'm concerned about is the. Maybe we'll hard code the scale. Because if things are big and small, you don't want the gizmo to get huge or very small, right? I think you just want the gizmo to be a size based on. I don't know. So we could play around with. Well, we can see how other applications do that and maybe follow suit. But yeah, so rotation. I guess we'll do that one next. So let's just start off on rotation. All right. Well, let's just hard code it here. All right. So rotation. This gets to use our new lovely torus, the one that we remarched this stream. So we need like we need to put it into we need a view from local matrix, right? So the way we get that is I think we have to get the actual matrix. So we have the world from local matrix. To do that, I've got a sort of a matrix 3D from transform 3D. So for that we can take that gizmo. Hopefully that works. Because I don't think I tested it before. And then we want to combine that and then do this torus stuff, right? Okay, so here's our torus. It's got some degree of thickness. This is 0.01 in local space. It's quite thick, maybe 0.05. Color red. So it goes across the XY plane to the Z first, right? Is that a good idea? Should I change the sign distance field function because that seems a bit strange to me? It should be going across the X. Wait. Yeah, the XY plane. Wait. Yeah, XY plane. We got it right. So, and that'll be the X-axis one, right? So we need to rotate it. So the view from local Y, I don't know which way around it is. So I assume we've got to add a little bit of rotation beforehand. Yeah, so you do it as the view from local X with the rotation. So we need to rotate it along the y-axis to get it to point down the x-axis and then around the x-axis to get it down. Wait a minute. Yeah, around the Z. No. Yeah, use the y-axis. We'll rotate it 0 degrees or radians. $90. And then we take the X one and rotate it around the X axis by 90. That'll get you the Z. Alright, those should be it. Just got to replace these accordingly. Bit of blue, bit of green. And hopefully that should be it. So it's going to be rotating around the x-axis. So see how that looks. Hopefully it looks alright. So got some Z fine. That actually looks alright. We don't know if it's correct though. We know one axis is correct. So let's actually kill the rotation. So it is actually being translated and then rotated as well, and because it's been translated back by 2. So the green, so red, green, blue, right? So obviously red X, green is Y, and this is Z axis. So I think I've got it wrong though, right? Because the X plane is, so this green one should be red, because that's rotating around the X plane. The X axis goes down that way, right? So it goes to the right. It goes to the right. And because of that, the plane is this green one, right? So that actually, the green needs to be where the red is. Sorry, the red needs to be where the green is. And then the green needs to be where the blue is. Right, let's write this down. Red to green. Wait, can I not just like recolor it? Right, change green to red. Change blue to green for Y. Then change red to blue, I guess, is the other one. Damn it. Yeah, of course it's going to read RGB in the end, isn't it? Is that right? Yeah, because I did an XYZ order, didn't I? Yeah. Right, so that one is going to be, yeah, the Z axis. That's good, that's good. So, let's swap back over here and fix it up. So pretty close, right? So green goes to red. So it's actually along the Z axis by default. Crying out loud. This is X. Red. Is that right? I don't know. Right, so that is correct. Yeah, they're correct. Good. So red goes to the right and left. Right, it's that sort of plane. Green is the up and down, and blue is the near and far, right? Ah, shoot. My laptop died. Let's put it back on charge. Right, so we're doing a good job. We just got to do the scale one now. So for the scales, maybe we should bring the thickness a bit down to be fair. It's a bit thick. Maybe it should be a bit thicker. Let's do 2.5. Right, and the final one is scale. Scale is going to work basically the same way as the translation one, but we're going to be having like cool. But what we're going to be doing is having the we put blocks on the end. That's what people typically do, is they put blocks on the end instead of cones. Where's my... Oh, I lost chat. Right. I'm back. Cool. Right, so the way we're going to do that is I think we've got to make a new kind of vector, which kind of sucks. So when I ray traced the vector, what I did is obviously a bunch of checks, and then I did a ray verse capsule and a ray verse capped cone. So typically what they do, let's get rid of that one now, is they will do, I need to do the planes, but yeah, they do like a, is that just another cylinder? Or they do a box sometimes. So maybe what we'll do actually is we could actually put a box over the cones and just use vectors. The problem is the cones are quite big though, aren't they? You know, let's just copy paste it. I don't know, it's got to be a OBB though, isn't it? Bit annoying to be honest. Because I could do my ABB verse ray, but what space is it in? In view space. You need to get into the local space of the object. Damn it. What's the best way to do this? Right, I want to try it. Yeah, but see, the problem is the cone gets sort of like minned or something somewhere. Yeah, there's a bit of a cap here, you see. Oh no, but it might be okay because the length is hard coded, kinda. Like it's always going to be the same shape. So we could probably get away by just doing a vector, but then just drawing boxes over it. Yeah, I think we get away with that. So why don't we draw the and then what we're going to do is draw boxes over it. It'd be a bit weird, but so they're 1 in length or something like that. And all we need to do is along that vector, that unit vector, We'll call it like UX yeah, I guess so. Shoot. Right. UX equal pay. You bugger. Alright, paste. Cool. So UX, Y, Z. So we should be able to use that to get the ABB, where to place the ABB, something like that. I might have to bring it back a little bit based on the thickness, I think. So now I'm going to draw a... I think I need a world from local. Need one of them. Draw an ABB. Center position in view space. I think that's perfect. It wants it in view space though, doesn't it? Yeah, so you got to transform these in a view space and then offset them. Is that really the center position? Is that take away a bit of thickness? Yeah, take half thickness along that vector. That's where it needs to go. This is a bit hacky. Let's just make it a shape for it. And do it in the shader. So we're going to make a new one. We're going to call it... is it a vector? Well, I'm not sure what you call it anymore. But yeah, when it's missing those plane things as well, we should get those done. But yeah, we'll call it like a... It's a capsule on a box, right, on the end. See, people sometimes combine them all into one. All right. So let's go ahead and do the plumbing for that. So in the shared header file, we're going to go ahead and add a new ones of these. I guess we need the world space one, to be honest. So we'll call it the vector box cap, something like that. World space. That will be good enough. So we'll go ahead and put it in. It's going to be exactly the same, but it's just got a different box cap. All right. Then we're going to make our way over to the GPU version. So that was the CPU side one done. Vector. This is the GPU implementation. So it adds it to a buffer instead of an array of an array. Adds it to a GPU buffer instead while on the GPU. Cool. So now we need to go to that vector type. And what we need to do is copy paste it, make more lines of code, and simply just trying to hack it together. So we've got the position of where the vector is going to start. The vector, we calculate the end position, bit of thickness, length. We do some checking to check for anything invalid and just don't bother trying to render it. If it's all valid, we get the cone length, which I guess is the box now. So already call this the box len, box thickness. So with this one, when we've got a length of a box, what is cone length then? Right, length, okay. So length is the thing across the vector, thickness is the thing, yeah. So we just want one of those. So whatever the length is, we're just going to take that. So we're not going to use thickness. So caps will start. Oh, we did a capsule. Interesting. And not a cylinder. Okay. So box starts, alright. Now I just got to calculate the ABB thing. So if we take the OBB code, what we need is this. Got to figure out how we're going to achieve it. Right, so we need an inverse view from local. No, we don't. Oh yeah, we do. So we need to somehow produce a view from local. The difficult thing about it. So I have this sort of wherever the vector is pointing, it needs to be like rotated to there. Can I do that with some of the quaternion stuff? I don't know what I've got, to be honest. Forget. Right, what have I got here? Anything useful? Right, forward and up. Yeah, I remember trying that. And it did work, I think. So we could do a look at, you've just got to somehow get an up vector, you've already got a forward. And that can get you a rotation. And then you turn that into a matrix. Um, yeah, you turn that into a matrix, and that'll get you the correct rotation at least. And then you need to do a bit of So we have like a, I'll do. So effectively you have a vector and we draw the capsule for it, and then we draw the box. That goes on the end. So what we need to do is we're defining a vector to draw it. Then we can turn it into a quaternion, but we need to somehow get a perpendicular vector. We need to know the up vector in which to rotate it around. When you just got an arbitrary. So we could take the up vector in world space or in view space, and then get the perpendicular, and then re-get the perpendicular again. Sorry, yeah, cross product, then re-get the cross product again, and then you get the actual perpendicular one pointing up or whatever. Yeah, my concern is though it's not going to be the one you want to rotate it around. So maybe you need more information. Wait, no. Oh. So this is always going to be aligned in view space, isn't it, or something like that? Yeah, it's always going to be aligned in view space. These vectors are always going to be aligned in view space. So I don't know why I'm rotating. No, sorry, always aligned in world space, that's what I mean. So I don't know why I've been rotating them. But anyway, that makes this problem a lot easier. We can always just... You need to get an up vector in world space. Move it to view space. Yeah, okay, I think of an idea now. What we can do. And that can get us a rotation. Wait a minute. We don't need that rotation at all. we can say the access line bounding box will be in world space. And we can move our view space position back to world space quite easily. We just need the, right. Yeah, I think we can do it. It shouldn't be too much work. So if we do graphics global, we can get the view. There's actually a world from view. So we need to invert it. So if you apply that to there, this will get you the world space origin and direction. I guess we did some checks here. Then um, if we hit, we need to transform it back into, so view from world. I don't know why I renamed all of this. Let's just keep it like that. So graphics global view from world. So we take the hit and we move it back into view space. Right, okay. Interesting. Should be alright, isn't it? Oh. Okay, so I think that's it. That's all we need to do. We're just limited to this being actually in world space though. But we're not going to use it for anything else. At least I hope we don't. So that should make it a lot easier to define. So actually, right, so when we go back to rendering these things, so this is like box cap world space. Right, so so translation never needs to be like whenever you always just do XYZ in world space. You never multiply and rotate the axes around. It doesn't make any sense. Does it? Man, I should just open up Blender, I think, and see what they do there. Huh. I guess it depends. I guess it depends on the editor, right? Whatever the editor wants to do. It might want to put the gizmos in a particular orientation. So perhaps we should let the editor do what it wants in that regard. But then my box cap one won't work. Right, let's just see it working. Let's not rotate it though and mess it up. Let's just let it do its. Right, why is this one complaining? Alright, so let's give it a run, see what happens. Let's test out the scale. Right, why is it complaining? 88. Why isn't that declared? Oh shoot, what is this? Oh, it's the OBB. Right, that's infinity. Let's declare this. Alright, give that a launch. What's going on here? That needs to be this matrix here. Alright, hopefully that works. Okay, we've got a box. We've got many boxes, all in the same place. So what they're just capsules here, but we want the box on the end, right? It seems all the boxes seem to be in the same place over each other, and that's because we've not. Right, we haven't added the we've moved the ray. Yeah, so the position needs to be adjusted based on the yeah, the position and the vector needs to be applied to these or something dumb like that. Okay. So you kind of just bring it to the local space of the. Yeah, so effectively this uh we need to add the add position and then also add the vector to it, I think. And then when we want to move it back, so we've actually got a hit, we move it back from local. We need to subtract it instead. Ugh. Alright, let's just give that a go. See how it goes. Alright. The boxes should be in the right place, they're probably bloody big though. Right, clearly not. They are moving boxes. Hey, Cap Payne. Yeah, I'm doing good, man. How are you? How's things? How's life going? Maybe it's the other way around. Maybe it's an ad than a sub, you know? These are still a bit buggered. Uh, I don't know what to do. I think we've got to make this work in more places than just world space. It's got to work in any space. Maybe we need to take this vector and make it a matrix. Doing alright, life is good, work is kind of busy, but all is well. Excellent. A better place to be, that's cool. Amazing. Amazing. Uh, hmm. I wonder how we could change this to make it work. See, being limited to world space kind of sucks. And hmm, maybe we need to send in an up vector in view space, and with that, we will have everything we need. We can use that quaternion thing or whatever it is. I forget what it is. We need an up vector. And then we can produce a matrix and take it into local space and do all the silliness we need to do. So that's the GPU one. I got to change its CPU side as well. Um, oh, I did it the other way around, isn't it? Damn it. Up. Let's go back to GPU, correct that. Alright. So, if we pass an up vector in, we should be able to do some cheeky maths to figure out the rotation that we need. And it can be independent of whatever space. But it's got to be in view space, actually, and not world space. You just manually have to do this outside if you need to. Right, let's get this sorted out. V space, get rid of the translations and that. So it was in V space with an up vector, whatever the up vector is. So inside the shaders, right. Let's see if we can work this one out. Okay, so I was able to work out. Right. So we need to convert this into. We can't really do it into local space. Ah, shoot. You can definitely get the rotation. Yeah, if you know what way the vector is going, you can get the rotation with the quaternion. Oh, so this would be local from view or something like that. Rotation. So it's like, look at quaternion. So the forward vector would just be vec, and the up vector would be up. So with that, we can get the way we need to rotate. So yeah, with an up vector, like how do we rotate along? What's the way of saying it? Yeah, how do we rotate around this axis, this plane here, to for this axis line bounding box, right? So we want to be able to bring it back the other way. Maybe I've got to reverse the quaternion and turn it into a matrix. And then we can apply, that's our, yeah, then turn that into a matrix. Hey there, Damien. Yeah, doing some, yeah, using ray tracing because that's the way our debug drawing works. We actually did a bit of ray marching today for the torus because it was way easier to do the torus with ray marching. But yeah, we're trying to draw gizmos. So these things. We've got the drawing. We've got the translation is done. We just need the plane ones to be put in there quite easy. We've done this rotation one. They do look better than this. This is not that good looking. And then we're trying to do this one here. But I already had a vector one, but I didn't have one with like a box on the end. So we're trying to like fudge one together right now, basically, because it's just debug code, right? It doesn't really matter. It has to work reasonably well. I guess I can tile, but I never want to make it better. I can just make it be quite complicated. But yeah, that's about it. How's things with you? You been working on much? Local from view. I think this code works. Pretty sure I tested it in the past. Wait, is that from a V? It at least just does the rotation bit, right? And that's all you need. Ah, Or is it from world? No, it's from view. Yeah, you've moved into view space. Right. So you simply all I need to do is apply a bit of rotation actually. I don't need the matrix. A bit full on. So all I need to do is rotate so the origin stays in the same place. But we multiply with a vector and a quaternion. Ray origin or ray direction view space. Radio. That's alright. Okay, then you perform your bordered access line bounding box hit, but it's not got border because we put infinity on the border size. Right, ray origin is in view space, isn't it? So all we need to do is apply a bit of rotation, get it back. So if we instead do the of to invert that and then mol v, that should get us what we want. Bit of a hack, but should be alright. I need to gives my mouse picking same code but CPU. Right. So what we're going to do is we're just going to, when we get the hit on the GPU, we're going to send it back over the GPU to the CPU and then just send it back a couple of frames late. So whenever you hover over something, you'll just tell the CPU, hey, it's hovered. And then you'll tell it which axis is hovered. And then the clicking is done on the CPU side. That should be alright. Yeah, so it saves me duplicating code basically. Well, not duplicating code, just sharing it across the two. Because I wrote it in the same language, so I could just bring it over, but it would mean I have to share it in some different files or something. I have to refactor, so this avoids a refactor. Right, seems like I completely messed that one up. A 1 in size? Is that a 1 is a bit big though, isn't it? Oh. How did they even compile? I didn't even save the file, damn it. Right. We need to combine that into a view space. We need to move these into view space, basically. Position view space equal mol point. Right, so that would be the correct one there. Now it's got to do the vectors. Yeah, I think that's actually not too bad. Nice. Um, so UX, UI, something like that. UZ. Hey Lupo. Doing good, man. Doing good. Just been jamming out some gizmos today. Made some reasonable progress. Just finishing up on the rendering, really. But we added like a torus. We remarched a torus and wrote up the Gizmo API, and we're just trying to get the scale one working and looking good. To be honest, oh, we need an up vector in. So the up vector is payload Gizmo. Oh, I need to work that one up out, isn't it? Wait, the up vector is shoot, but they're going to be pointing the same way. Oh, if they're pointing the same way, okay. We're going to get a bit of a mess up on one of them. Alright, we're going to give that a launch. Listen to post-rock. Not sure really sure what that genre is, to be honest. There's a lot of rock and metal, but yeah, I listen to rock metal, basically. That's what I typically jam along to. I wish I knew how to pick in a way that doesn't need me to read a pixel from a texture on GPU. That takes me 2 to 3 milliseconds, huh? How does reading pixel take 2 to 3 milliseconds? I'm not sure what that means. Yeah, I'll give it a go. Nice. I'll leave this open. Thank you. I'm gonna have to pack up soon. But yeah. Actually, maybe we can switch over to it. Let's just leave it on now. Right, see how this goes. Hopefully the stream doesn't die. Right, we're still here. These are not axis-aligned bounding boxes. This was working before, right? Oh, the capsules are messing up hard. Multiply point. No, it's a vector, my friend. Crying out loud, what have you done? They're so thin. They exist though. Oh, the thickness didn't get transformed either. So the thickness... No. Yeah, I thought that was a bit strange. I was like, what's going on? This is a weird genre. Length. Alright. These to multiply it by the word. Hey, so what's going on there? Can I make it a bit thicker? Okay, clearly the parameters might be passed in wrong or something. What am I doing? Shaders. You know what I didn't do? I'm reading the wrong word in the shader, aren't I? Yeah, thickness has been read from 7 instead of reading from 10. And then color, wherever that is, should be read from 11. Right, let's fix that. That's good. Right, so the capsule should be rendered correctly now, as they were before, but the boxes are still not there. I don't know what this logic is doing. So that should produce the rotation. Maybe let's just try identity quick. Hey, the devastated. Yeah, it's going good, man. It's going really good. Don't I have an identity quad? Oh, what's going on? Yeah, we're just working on the gizmos, and we got most of the rendering done. We're just trying to do the final one, which is the scale. My code doesn't work. Like, we put cones on the end of a vector for the debug rendering. We don't put boxes, so it calls me to have to write a new thing. But we've got the API in. We've written a ray marcher for the rotation thing, so it looks quite nice actually. And we're just about to finish up on the rendering, hopefully. But yeah, then after that, we've got to do the hovering code on the GPU. Just the ones that have hit, note it down and tell the CPU that we've actually hovered over the X gizmo thing or whatever. But yeah, it's been going good. How about you? Oh my days, it's the other way around. That's inconsistent. Still don't see no damn box. Mm-hmm. I was hoping we would see. Oh no, because then it would be in view space. So it'd be right where the camera is, wouldn't it? Basically, I think. Yeah, so we might have to apply some offsets and things. Right. I think we'll put a pin in it today. But we've got some ideas, right? I think I should be able to work that out next stream quite easy. And then we can do the hovering code and actually test things moving around, or moving the gizmos around and making them react. So hopefully just one more stream. If not, it'll be a couple, 2 more streams, but it should be. It's getting close, right? Yeah, what we're saying. Gonna put it with me too good. New house is about a week. Amazing. Counting down the days. Have you packed everything? You all packed now? It's not bad there, Lupo. I'll keep it open. So maybe we can continue playing it next time. Let's find someone to raid quick. Well, maybe not. I've got a jam. But yeah, thank you for coming. I'll see you all in a future one. Have a good start to your weekend. I'll see you all on Sunday. Check the timetable if you're interested in when that is exactly. But yeah, have a good one.